Hello and welcome to Jester of Blades, this time from my wonderful little office. It's been a while since the last video, and that was due to me having 2 weeks of well-deserved vacation. Did some mountaineering, had a wonderful time, but now it's back to work, and this time I'm taking you with you for a little bit of a different thing, because as you might know, I machine my blades. I CNC machine my blades out of high strength aluminium. Well, most of them at least. And that requires some preparing that I do on the computer here. And that's why I thought I'd bring you with me into CAD. I'll start OBS quickly and then do a screen record for you so you see what my work looks like in the computer, and you might already be able to see it on the screen. Whoops. There is the Halberd. And with this, welcome into CAD. If you don't know what CAD does, maybe a quick demonstration. I can, for example, do a sketch and draw some interesting shapes on here. I can do circles, I can do lines, I can do rectangles, and I can do one more line, and I can choose the dimensions of the shapes that I want. So maybe this circle is 275 millimeters and this here is 100 millimeters. And if I'm satisfied with how the sketch looks, I can finish the sketch, and then I can do all sorts of funny things with my sketch. I can, for example, extrude my sketch. So there's then this funny shape. I can do also some revolutions around an axis, which doesn't work at the moment, I fear. Maybe with this profile. Yeah, with this profile it works. So then it just revolves this shape that I drew around an axis. Or if I have extruded it, let me quickly extrude it, then I can modify this shape with a fillet, for example, or I can take a chamfer to the inside edge here, or I can drill a hole into it. So that is what a drill would do to the part. And I can, of course, change the size of this hole. And what makes this whole thing so interesting is that I can always change this, even if it's already there and done. So I can, for example, change the radius of this fillet in the aftermath, or I can change even the sketch. So if I want this to be 70 millimeters, I can make it 70 millimeters. And I've finished the sketch, and then it becomes bigger. Maybe not that apparent in this case. Let me do it once more. For example, with this shall be 50 millimeters. Oh, no, this will not work. So there is some limits to what you can change. 60, for example. 60 should work. So this becomes smaller. Alrighty. Let me quickly undo this and then show you what I did to the Halberd. And the Halberd is basically done all the same way as this shape that I showed you earlier. Of course, some of the sketches are a little bit more complex than what I did to demonstrate. But let me quickly show you around the model here. So basically, this is a wooden shaft. You can see here. It's got 2 languets on either side that will attach these 2 stabilizers. You maybe already know those stabilizers from the aluminum dussex. It's basically done the same way. Thanks to Dave Rawlings at this point, who pointed me to this idea and said, hey, why don't you try this? So thanks a lot, Dave, for bringing this idea to me. And yeah, I hope you will be happy how this turns out in the future. So, yeah, stabilizers in the middle here. There will be a leather blade sandwiched in between the stabilizers. This leather blade will be twice the thickness of the blade on the aluminium dossags. On the back here, there will be some hook shape, so you can hook somebody's legs or his neck or whatever you feel like. On the top here, this is not the final approach. I think I thought about putting a leather ball there. Might change my mind about this a couple of times. Let's see how this comes out. If you get any suggestions on how I could do this top part here, then just let me know. So, CAD is all well and fine, but of course, it needs to become reality. And that is where CAM comes into play. Welcome to the manufacturing part of this video. So, CAM systems basically do one thing, and that is converting this model that I have into a code called G-code that my machine can understand. And for this to work, I first of all need to tell my computer what the stock material looks like that I want to machine out my finished part. And I can edit the stock here in setup. So this is perfectly adapted to the size of part that I want to machine. I have it being 2 millimeters bigger than the part I need to machine. So this shade, yellow shade you see around the part, this is what the stock material looks like, and it protrudes 2 millimeters on every edge of the part. I could change this like 50 millimeters. You see, it becomes way bigger. And this, of course, wouldn't make any sense because there would be a lot of waste material. So let's stick with 2 millimeters. Another interesting thing I could do in setup is, if you see this funny shape up here in the corner, I can put this anywhere I like. So basically down here or in the middle of the part or in the bottom of the part. I want to keep it up here because this is my coordinate system. This is where the machine starts machining, or this is the 0 point where the machine knows this is 0 on my part. And every measurement is measured up from this point to any part of the part. So I don't want to change anything, so I will abort this. And we will start into some operations that I can do. So in Fusion 360, there are basically two distinct ways of going about making your part. There's for one 2D and there's for the other 3D. This is kind of misleading because 2D is actually just two paths that are dumb, so to say, and 3D is two paths that are more intelligent, so to say. Difference being, with 2D I need to tell the computer what to machine away, and he will ignore the rest of my model completely. With 3D it will take the model into account, and I will have to tell the computer what not to machine. This part is entirely capable of being made in 2D mode, and this is the best way of doing it. If you can keep it simple, keep it simple. No need to overcomplicate things. So the first thing I go with is making the holes. And since my machine is not really capable of drilling, I need to machine these holes using an end mill. And that is where this boring operation comes into play. Because this boring operation, I can simulate it quickly for you. and I can even simulate the stock so you can see what gets machined away. This boring operation will ramp down into the holes and thereby machining out the material. So close this, and then there is another very interesting operation that is really the bread and butter operation in CAM, or the operation that does the most work for me, and this is 2D adaptive clearing. And you can already see where the toolpath cuts out these pockets. 2D adaptive is cool in this respect because I only need to tell the machine where the pockets are that need to be machined away, and the computer will take care of making sure that the end mill has always the same load on it. So you can see like it's circling down in here, and it always makes sure the end mill is only plunged in a amount I specified in the operation. So I can specify how much radius of the end mill has to be in the material optimally. Of course, there can be some deviation, but you can also specify a minimal radius that the end mill can be plunged in. And the computer will work around this and make sure that your end mill will always be in these limits and therefore work in the perfect way. So this machines away the pockets. I can quickly simulate it for you here. So it ramps down into the hole and then starts machining out the bulk of the material. And this happens to all 5 of these pockets. And then the machining is complete for these pockets. But 2D adaptive doesn't leave a very nice finish, which is why I have a 2D contour cleaning up the outside of the pocket. And then 2D contour is also used for machining out the perimeter of the part, because I don't want to machine away all the raw material that is in excess. It's faster to machine around the perimeter and just leave it be and just throw it away as is. So I can simulate that quickly for you. And as you can see, I can turn off the model, then you can see what gets machined away. As you can see, it ramps down the perimeter of the part. This is due to the fact that I'm not able to evacuate the chips, well, at least not properly, if I take it in one depth of cut. And if you look now, I can just disable the tool. If you look now, these parts stay attached by tiny little tabs. They are only 1 millimeter thick, or 1 millimeter thin in this case. So they stay attached to the stock and give it added stability, because I'm still using superglue machining for this part. So the more area I have to adhere to my platter, the better the setup will be, or the more rigid my setup will be. And these things coming loose pose a real threat to my end mill. They could, if they come loose, they could break the end mill, which would, well, of course, destroy the end mill. So that's to be avoided. That's why there are tabs here. With this being done, quickly re-enable the model. There are just 3 operations left, and they are all chamfering the part. And I'll just quickly simulate everything here, so you can see how this part comes together. Tool ramping down into the holes, boring out the holes for fixing it to the leather blade. 2D adaptive, cutting out the pockets. Then the 2D contour, cleaning up the pockets. Then the 2D contour ramping down around the part. And then this is the chamfering, so I'm spiraling down into the holes and getting the chamfer that way. And it's the same with the pockets. All the pockets get chamfered because it just looks nicer that way. And it also doesn't pose any risks of getting cut on a sharp edge, which would of course be pretty dangerous in HEMA. And for finishing, these two holes will get a small chamfer around the outside, and that's it. So, neat thing about CAM is I can already look how much this part will take to machine, how much time this part will take to machine, and it would be a 15 to 16 minute part according to this. However, this is not entirely correct. The computer can't take into account how much time the machine will spend in accelerating and decelerating, and especially in adaptive moves, this is quite a lot of time. So in my experience, this is a 20-minute part, around 20-minute part. So everything that remains to do now, the final stage would be post-processor. And the post-processor does the following. It takes what Fusion has done here, so these contour steps, and Fusion already calculated the tool paths, but the post-processor will translate the tool paths into G-code. And I can quickly show you what that looks like. And there we have the G-code. That is what the machine actually understands. And I will not go over it in detail. Just for starters, you have the boring operation here. It uses tool 11, then the spindle gets turned on at 20,000 RPMs, and then some coordinates get the machine drives from coordinate X to coordinate X, and this continues and continues and continues until you see it's quite some code. A lot of lines, especially the adaptive has a lot of lines. And there is the end of the code at 17,000 lines, and you can imagine what it would mean to write these 17,000 lines yourself by hand and not having a CAM system for this. So that is what I do in CAD and CAM. The machining part will be in another video. The next step is to order raw materials. I have already done this. They should arrive end of this week, beginning of next week. Let's see. And of course, I will bring you along for the machining of this halberd and for the assembly of the halberd and some other steps involved in the making of the first prototype of this halberd. And of course, I will bring you a video on how this halberd performs and maybe the whole process of how this first prototype will turn into the first serious batch of halberds. So what I want to say is, stay tuned. If you like this video, please subscribe, it really helps. If you have any suggestions on how I can improve this halberd, leave it in the comments down below this video. I'm really fond of hearing your suggestions and your point of views on this halberd project and what you would like to maybe see included even in this halberd project build. And with that, I will leave you. As I said, follow the Jester to stay tuned, especially on this halberd project. And I'll see you next time on Jester of Blades.